Hello all of you. Today I'd like to delve into shaders and their inner working structures. In recent times, I've seen a lot of inspiring work, like Sebastian Locke's video on slime simulations and AC Roller's pixel sorting algorithm. And I got motivated to try writing a shader on my own. The main goal of this video will be to create a sphere that wobbles a bit like this. The main thing to get started we have to understand before we begin is the properties of vertex shaders and fragment shaders. Those are the main way we're going to be communicating with the GPU how we want to render an object. In very broad terms, vertex shaders are changes to the transform of a vertex. And in contrast, fragment shaders are determining the color of a pixel. Today I'd like to focus on vertex shaders. Alright, now that we are all on the same page, let's begin with creating our sphere. This will be our base object for now. To write a shader for it, we will need a custom material with a default unlit shader and apply it to our sphere. That's it for the setup. Now we can start with writing the shader. Let's keep a window of our view on the right bottom, so we can keep track of our shader. This is our vertex shader. You can ignore the line about Unity fork right now, as it's not important to us. You can see here we are defining the vertex transform and the UV texture position. In our vertex shader we are referencing two structs. These are shown right now on the screen. They automatically get defined by Unity's graphics API. Before we try to start accomplishing our goal, let's have a bit of fun and experiment. What would happen if we were to set the transform of our vertex to time encapsulated by the sinus function? Well, that's not quite what I wanted. How about we try doing the same thing, but adding the vertex position to it, so we get the baseline for the transform. I didn't expect this behavior to occur, but I guess it looks like that because we were seeing a 2D cross-section of the object rather than an actual 3D object. How about we isolate an axis and then apply sign to that, while keeping all of the other axes untouched? This makes sense because we are absolutely defining the x-axis of the vertex. Let's do the same for all of the axes now. Now we just end up with a point like here. So to circumvent this, we can just multiply our original vertex position to the sign. Hey! We've got an oscillating sphere now. How cool is that? We can achieve it in so few lines. Let's add an offset to the sign so the circle doesn't disappear. Now that's much better if you ask me. Here I just multiplied the sign by the original input vertex x position. In this one you can really see the sine wave. I think this is a great example for why I wanted to try writing shaders on my own. Now this code is ultimately what I ended up with to achieve the original shader image that I had in my mind. I think it came out pretty well if you compensate for my lack of knowledge. I very much encourage you to write your own shader, even if you don't have any idea in mind. This really opened my eyes towards interacting with the GPU, and maybe I'll even do a follow-up once I'm more experienced. Let me know in the comments if that's a good idea. Consider subscribing, I would really appreciate it, and have a very wonderful rest of your day.